Okay guys, this is a homework check video for worksheet 11-1 practice 10 through 20. Would have been like Tuesday's assignment. Today's Wednesday, so it would have been yesterday's assignment. I already got these problems worked out for you, so I was just going to scroll through here really fast and maybe double check, make sure that they're right. Double checking with my answer key real quick here and make sure I got this right, because I don't want you to be doing the wrong thing. Alright, number 10. This is a pretty simple one. I mean, all of this over here is what we call perfect squares. So, but I still do it the same way. I mean, if you recognize that the square root of 16 is 4, the square root of b4 is b2, then I mean you could just write the answer and kind of skip all this work over here. But the work kind of shows you where it comes from. So I'm still doing factor trees as much as I can on this page. 16 is 2 times 2 times 2 times 2. You look for pairs of 2's. You pull out each pair. You pull one of those numbers out. So I got 2 2's to come out and 2 b's to come out. Put it all back together. That's where the 4b squared comes from. Okay, number 11. Same kind of deal. Everything here is perfect squares. 81 is 9 times 9, c squared c times c, d4 is d2 times d2. So I can look at it and tell that's the answer. But I'm going to do this with the factor tree. Break it down into prime factorization. 3 times 3, 3 times 3, 2 c's, 4 d's, and circle pairs. There's a pair of 3's, there's another pair of 3's, there's a pair of c's, there's a pair of d's, and a pair of d's. Put all that together, it's 9cd squared. Number 12, factor tree again. All of it don't come out this time, so that means this is not a perfect square. 40 is 2 times 2 times 2 times 5. You got 4 x's, 6 y's. I've got one pair of 2's. I've got 2 x's that come out. I've got 3 y's to come out. Right? So no extra letters left over. So you multiply this together, it's 2x squared y cubed. That's out front. What's left over is in this blue box, 2 times 5. Those are the ones that didn't have pairs or partners with them, so I'm going to put those back together under the radical sign to get a 10. Number 13, I've got a 75 m5 n squared. Break that apart, it's 3 times 5 times 5. I've got 5 m's and 2 n's to write out. I'm looking for those pairs. I have a pair of 5, so 1 5 comes out. 2 pairs of m's, so 2 m's come out. And I got a pair of n's, the n comes out. What's left over inside is 1 3 and 1 n. I'll do that in green here. There's the 3, and over here's the m. So they both go back under the radical sign, right? Anything that doesn't have a partner. Multiply everything together out front. 5 times m times n is 5m squared n. And then multiply everything inside. 3 times m is just 3m. So final answer, 5m squared n outside with 3m inside. 14. Got fraction here, pretty simple. I'm just multiplying the top and bottom by the square root of 3 to get the square root of 9 on the bottom, which simplifies to a 3. And the square root of 5 times 3 makes the square root of 15 on top. You know, I'm not going to go through the trouble of making a factor tree for 15 because I know that there's no pairs of factors in there. So final answer here is square root of 15 over 3. 15, same kind of problem. I've got the square root of 1 on top, square root of 6 on the bottom. Multiply both of those by square root of 6, square root of 6. So you get square root of 36 on the bottom and square root of 6 on top. Square root of 36, you know, is just a 6. Now, if you guys want to take and break it apart into 2 times 3 times 2 times 3 and do your pairs of factors, you're going to get nothing inside and a 6 outside. But y'all know 36 is a perfect square number. 16, a little bit harder here. You do this a lot of ways, but I multiply the top times top, which is going to be a square root of 6. Bottom times bottom, which is going to be square root of 21. I just showed you all that work, but that's all it is. Then we're going to rationalize the denominator, which means we're going to get rid of that radical sign. I'm doing the square root of 21 on the top and bottom, so multiply by that. Gives me a couple of big numbers. The square root of 441 is actually just 21 on the bottom, and the square root of 126. I put a question mark here because I don't know if there's a perfect square inside of it. So I went ahead and made a factor tree for 126. So you do actually have a perfect square in there. If you do 2 times 3 times 3 times 7 for 126, you see that there's actually a 9 that's hiding in there. It's got to come out. So pull that 3 out front, right? You find a pair of 3s, pull one out. What's left inside is 2 times 7 is 14. So I got 3 square root of 14 over 21. At the end of the problem, anytime you have a fraction, you've got to check. Again, you can't reduce anything with the under radical, right? You can't touch the 14. But what I can reduce is the 3 and 21 because they're both outside of radical signs. So that's like a normal fraction. 3 over 21 reduces to 1 over 7. So I have a 7 on the bottom, the 14 on top. And again, I can't reduce to 14 and 7 because 14 is in the radical sign and 7 is not in the radical sign. So final answer, square root 14 over 7. 17. I got to rationalize the denominator, multiply by the square root of 12. If you wanted to take that 4 out of there first, you could, but I'm just going to keep it in, do it all at one time. So multiply by the square root of 12. It gives me a square root of 12p on the top and a 12 on the bottom. The 12 I know has a 4 in it, so I'm going to do my factor tree and pull it out. There's a pair of 2's, pull the 2 out, 3 q's left inside. Now the 2 and the 12 reduce to a 1/6, right? Because 2 goes into both of those. So I like square root of 3q over 6 for that one. Number 18, rationalize by multiplying by the square root of 5 on the top and bottom. That gives me the square root of 20, h, over the square root of 25, which you know is just 5. Can't really see, but that's square root of 20h again. Again, I know that 20's got a 4 inside of it, so I'm going to break this apart. Factor trees 2 times 2 times 5 times h. Pull out that pair of 2's as a 2. Leave that 5 and h behind. Now you have 2 over 5. This time you can't reduce your fraction. So my final answer is 2 times the square root of 5h over 5 for number 18. Number 19, I'm going to, not really going to go to the trouble of rationalizing the denominator here, guys, because I know the square root of b squared is just b. I mean, y'all should know that. That's pretty simple. So I just went straight to b there, and then I simplified the 12 by doing 2 times 2 times 3 and pulling the 2 out. So my final answer here is 2 square roots of 3 over b, right? I think you can all kind of shortcut that problem. Last problem's kind of the same way. On the bottom, I got the square root of 4m4. Okay, that's a perfect square, and I can see that without doing much of a factor tree. The square root of 4 is 2. The square root of m4, I've got it wrong. I think it's supposed to be m squared, right? Let's do that. And on the top, 45 can break apart into a 3 times 3 times 5. So, right there, that 3 times 3 is going to be your pair of factors. Pull one of them out. So on the top, 3 square roots of 5, and on the bottom, 2m squared is what I'm supposed to have. Okay? All right, that's the homework check for today. Again, today is Wednesday. You have a quiz tomorrow on this. I'll be studying over this a little bit, right? Today's assignment is going to be that worksheet 11-1, but I think today's going to be the study guide side. And I think for the study guide, I gave you problems 9 through 22. Okay, so working it down 9 through 22 is, I think, what the assignment is, study guide side.